Hello everyone. Today we will be learning a concept from inequality in algebra. We will do that using a problem from RMO, Regional Math Olympiad India 2003. This is problem number 3. I'll talk about the problem in a moment, but let me first discuss the main goal of today's video. We want to learn a concept called Quadratic Mean Inequality. But as usual, we would like to understand this concept in the context of a problem. That's how we learn things. We learn things if we know how to apply them in a problem. And this is the problem that we will be applying it to. We will also talk about a strategy, a problem-solving strategy. It's called sum it up. It can be used in various other situations. We will learn how to apply it in this particular case. So what is the problem? It's given that a plus b plus c is equal to 1. There are 3 real numbers and all of them are positive quantities. Whenever you are dealing with positive quantities, you immediately tell yourself that the power mean inequality, that is the AMGM inequality, can be used in this particular problem. In fact, we will use it. Quadratic mean inequality is just a sub-corollary of the power mean inequality. Now, with this given data, what is our goal? Our goal is to show that the minimum of these quantities, A minus AB, B minus BC, C minus CA, the smallest of these 3 numbers will be at most 1 by 4. The smallest of these 3 numbers will be at most 1 by 4. And the largest of these 3 numbers will be at least 2 by 9. So it has to be greater than or equal to 2 by 9. In this video, we will be working on the second part of this problem. If you know how to solve the first part, why don't you put a comment in the description? So let's talk about the quadratic mean inequality. It works for 3 numbers. In this particular case, we will be using it for 3 numbers, A, B and C. And it says that a square plus b square plus c square by 3 raised to the power half is greater than or equal to a plus b plus c divided by 3. That's the meaning of quadratic mean inequality. That's the statement of it. So how are we going to use it? Well, we will use the strategy of sum it up, and we will apply it in the second case. Let's try to do that. So we will simply add up these 3 quantities, A minus AB plus B minus BC plus C minus CA, and assuming contradiction, that means we will assume that this is not true and show that we will end up in something wrong. So assuming contradiction, we can assume that all of these quantities are less than 2 by 9. Each of them are less than 2 by 9. So sum of them is less than 2 by 9 plus 2 by 9 plus 2 by 9. Right? All of them are less than 2 by 9. So sum of them is less than 2 by 9 plus 2 by 9 plus 2 by 9, which is 6 by 9, which is 2 by 3. So assuming contradiction, we start with this statement and we will show that something goes wrong. That is A minus AB plus B minus BC plus C minus CA. If we assume that all of them are less than 2 by 9, then the sum will be less than 2 by 3. Now A plus B plus C is 1, so 1 minus AB minus BC minus CA is less than 2/3, or 1/3 is less than AB plus BC plus CA. So I'll write it in the other direction. AB plus BC plus CA is greater than 1/3. This is the conclusion that we get if we assume that each of these pieces is less than 2/9. We will show that something goes wrong. Something goes wrong. And therefore we will achieve a contradiction. So here is how we will start. So we'll start with the fact that A plus B plus C is equals to 1. So let's square both sides. Then we will get A square plus B square plus C square plus 2AB plus 2BC plus 2CA is equal to also 1, because 1 square is 1. Now we already know that A square plus B square plus C square by 3 raised to the power half is greater than or equal to A plus B plus C by 3, which is simply 1/3, because A plus B plus C is equal to 1. Now let's square both sides. So if I do that, I'll have A square plus B square plus C square is greater than or equal to 3 times 1/9. So this one is squared and the 3 goes to the right hand side. So we have 3 by 3 cancels, so this is 1/3. So A square plus B square plus C squared is greater than or equal to 1/3, which means that if I add 2AB plus 2BC plus 2CA to both sides, 2AB plus 2BC plus 2CA to both sides, this is what I have. Now this left hand side is simply 1, so I'll just write it as 1, and this one is greater than or equal to 1/3 minus plus 2 times AB plus BC plus CA. So if I bring the 1/3 to the left hand side, I will have 2/3 is greater than or equal to 2 times AB plus BC plus CA. So 2 and 2 cancels. So I have 1/3 is greater than or equal to AB plus BC plus CA. Now earlier we have AB plus BC plus CA is greater than 1/3. So we already found a contradiction and we showed that something goes wrong applying the quadratic mean inequality. I would like you to tell me why the first inequality is also true. We already proved the second one. And also, if you have seen the application of quadratic mean inequality in some other problems, then you can also share it in the comment. I have shared some more videos and other links, useful links in the description. Check them out. Thanks for watching this video and keep on doing great mathematics.